let's talk about the table some more. And to do that, we're going to need a function. Let's use this right here. So y equals 2x plus 4. And I want to make an input-output table that displays these x values here. So 2, 5, 8, 11, and so on. So first I'll go to y equals and enter my function. So 2x plus 4. So that's done. Now, since I'm going to be going to the table, I want to prep it first. So I'll go second window, and my first x value I want is a 2. So I'll make that a 2, and my delta table, that is the increment for the x values. So my x's are going to increase by 3 each time. So I would like that. Now everything's set. So if I go to the table, second graph, there it is, 2, 5, 8, 11, and so on, and the corresponding y values. So that's it. Okay, let's do another one. So how about this one? Y equals 1 minus 5x. Okay, so I'll go to the y equals menu, 1 minus 5x. Okay, then I'll go to the table setup, second window. And this time, my starting value is 5. Cool. And this time, my y values are dropping by 4 each time. So dropping by 4. And I get exactly what I'm looking for. 5, 1, negative 3, and so on with the corresponding y values. So yeah, your increment can be a negative number. Well, let's do another one. How about this one? Y equals x squared plus 1. So I'll go to y equals, clear it out, x squared plus 1. Okay, then I'm going to go to second window, and my first x value is a 1. And my x's are increasing by 1.5 each time. So 1.5. So I can do that and then go to the table, and I see exactly what I'm expecting to see, and everything's hunky-dory. So yeah, your increment, that can be a decimal number. So can your starting value. I haven't done that, but yeah, you could say, well, I don't want to start at 1. I want to start at 1.6 or something. Okay. And then from 1.6, add 1.5, you get that. Add 1.5, you get 4.6, and so on. So those are some things that you can do. What if I had something like this? Another function, nothing terribly exciting, 2x plus 3. However, the x values, they don't follow a nice, neat pattern. So now we're going to do what we did in that other slideshow about the table. Okay. We'll go down here and select ask. I never use this ask. You can turn it on and go to the table and see what it does, but I don't find it terribly useful. But now when you select ask, the calculator will ignore these numbers here. You can change them if you want, but it will ignore them. So when I go to the table, I can just type in exactly what I want. 190, 857, 23.9. Boom, and I've got exactly what I want. So that can really be handy. Now, let's change this up to explore something else just real quick. What if it was something like x to the 50th power? So a really high-powered function where the function grows very rapidly. Okay, so and what if I had something like this? Okay. Well, first of all, I'm getting an error there because 857 to the 50th power is too big for the calculator to handle. It can handle very large numbers. It can handle numbers up to 100 digits to the left of the decimal point, or 99. But this is considerably larger. So we get an error. But what if we say, when x is 23.9, give me just a little more information about the y value corresponding to it. So if I highlight it, notice down here, I get some information. Okay, right here, I just see 8.3 times 10 to the 68th, but down here, 8.3156278946215 times 10 to the 68. So you can highlight the y value and get more information down here where applicable. So that is also something that can be quite useful. Anyway, that's it.